Okay, so I've got some code here from Develop the website, and it's a Leisen Reimer binomial tree. Binomial construction, whether it's for Cox-Ross-Rubinstein or Leisen Reimer, is more or less the same. So the structure of the tree and the backwardation is the same. What changes is principally the risk-neutral probability and how we do the backward induction in the sense of the terms that we estimate. So, for instance, we use P in 1 minus P, same as Cox-Ross-Rubinstein here for Leisen Reimer, but the way we calculate P and PP is different, and these are specifically related to the Leisen Reimer setup. So just to examine a little bit how functional this is, and to take the code out of Visual Studio for a moment and put into an online compiler, because it's a single script, the code should work without too much difficulty. So we'll just copy that, and then I'll go to an online compiler that I've been using now a little while. So the address here is online and then gbd.com. So if we run this code, it'll execute hello world, and so long as you just have a single segment of script with the main defined, this code should run without too much difficulty. So let's just run this code for a moment, and we can see the American call is worth 20, American put, so European call, European put, American call, American put, and these are values that are generated from this Leisen Reimer code. So if we just examine C out, we can see that we have a European put, American call, American put, and we can verify our results here, for the American call at least, by first of all just looking at what were the parameter inputs, and we have the spot price of the stock, the exercise, the time to maturity, risk-free rate, dividend yield, and volatility. So the volatility of the annualized return. Now, those parameters I actually took from Brody and the Temple, 1996. So their article, New Bounds. Okay, so let's just rotate this to have a view. Okay, and we can see the value here that we get for given these parameter inputs. So let's just go back and check with Brody and the Temple. So if we take the figures that we have here in table 1, page 1, 2, 2, 3, we can see we have these parameter inputs. So just to compare, we have 300 steps. That's something we have decided to use here. This is not, Brody Temple do not use Leisen Reimer. They use Cox-Ross-Rubinstein at 15,000 steps. So our 300 step Leisen Reimer, and there's a lot less steps here, but the spot price of 120, the exercise is 100K, and we have also, we're taking the value of 120 for the spot, 100 for the exercise. The period is 0.5 years, so 6 months. Risk-free rate 3%, 3Q, dividend yield 7, and the volatility 20%. So we can see here we have all those values: volatility of 20%, dividend 7, risk-free rate 3, time to maturity 0.5. If we run the value with 120, if we take the spot price, asset price, to be 120, this is the true value at 15,000 steps, 15, and being 15,000 steps in a Cox-Ross-Rubinstein tree. Okay, so we can go back to change this to 100 and see what happens. So 100, run again, see what result we get for the American call. Now we have 4 outputs here: call, put, call, but American call and put, and we have 4782 4782, and we go back to go back to Broadview Temple, and we have 4783. So let's do one little additional check here. But the value then after, so 4784, so okay, so we're close to a 5 here, which would round us up to 3. So we're relatively close, not exactly the same, but very, very close to a binomial tree with a Cox-Ross-Rubinstein 15,000 steps here for the American call option. Okay, so when we'll do one more estimation, maybe at the 90. So we'll just 90 and run again and see what value we have for the American call option. And for the American call, 1386, maybe around the 627, and go back in to Broadview Temple. So for 90, 1386, 1386, and we have here 1386, and perhaps we would have rounded this one to 7. So again, fairly close. Using this Leisen Reimer, we can say we're relatively close to, if we increase the number of steps here maybe to 1000, we might get a little bit closer. So delete 1000 and run. See what results we get. So here we have 13865. Let's put it to 5000. Now this compiler is relatively fast, but the code that we put in here has to be sent to a server, and then once the estimation is done, those results have to come back via internet. So broadband can be relatively fast. Again, might be worth pausing here for a second. Okay, so a good minute has passed here, and this hasn't executed. Normally, if it doesn't execute, it just reports killed, and I'm not getting that back. Okay, so we've got results here. That's fine. 1-3. So for the American call, although this time it's a little bit slow, but you'll find if you had put this set of values into Visual Studio, also it would have taken quite an amount of time to execute. Also, the number of steps here is we have to have for Leisen Reimer, you need odd steps for Leisen Reimer tree, so it adds one additional step to whatever you put in, typically if the number's even. The value we have here is 1386. Go back to our first value here. So when the spot price is 90, we have 1.386. Okay, so we're getting pretty close to what we might consider true with this Leisen Reimer. Okay, we just go back. Now, Leisen Reimer then is a kind of a useful tree. It's an additional check, I suppose, for implementing option valuations, and the code here that we have, I'll leave in the video clip. Beneath the video clip, I will leave a link. So I will share this code, and we'll take this share code. I'll just take this code here. So copy, and I'll put it in underneath the video clip in YouTube.